Kerberos is the name of this three-headed dog. Greek mythological character, which could be called Kerberos, and this is a dog of Hades, guarding the hell. Why would they want to guard the hell? I mean, I can see that you want to guard the heaven. No authorized entry here. But anyway, so the Greeks wanted to guard the hell. And this is the protector for the MIT's system, basically. So this system was started at MIT. And actually the people who started this thing, all of these were my colleagues because they were working for digital. And in fact, the whole Schroeder company that we mentioned, they're all digital employees. So anyway, so designed originally for Project Athena at MIT. So they designed a system, and MIT basically solved this problem, which we all now use everywhere else, is that they didn't want people to log in every place separately. You go to this room and then you log in a different computer. You go to this room and different computer, you log in again, and you have 15 different passwords. So they said, let's just make one place. So they started this system, Kerberos. So Kerberos is freely available from MIT. Version 4 is available. Version 5 is a standard called RFC 4120, and everybody uses Kerberos. Windows 2000, XP, Server, Vista, they use Kerberos. Apple, Mac, OS uses Kerberos. Apache, Server, NFS, OpenSSH, you name it. It is designed to protect against eavesdropping and replay attacks, and uses the KDC. Actually, we will call here Authentication Server, and I will tell you in a minute as to why it is called Authentication Server. And symmetric key means secret key. So first three versions are no longer in use. Version 5 is a generalization of version 4. Version 4 was designed just for MIT, and actually not for MIT, but something like MIT, and now we have generalized it so anybody can use it, version 5. So we will explain version 4 first, and then we will go to version 5. So this is how it works. They divided the KDC into two parts. First is called Authentication Server, another one is called Ticket Granting Server. Authentication Server is the one that keeps your secrets. That has to be really put under lock and chain. That's very secret. But once you have your, the other part, like the KDC was giving you tickets, that doesn't have to be kept in a lock and key. Okay, so that was taken out, and that was called Ticket Granting Server, TGS. So you could put all of them in one box and protect it, doesn't matter, or you could put in two boxes. All right, but the functions are separate. So first you say, okay, here is me, and I would like to use the network today. And so then it gives you the Authentication Server, authenticates you. Basically, you will send your password or whatever it is. It will say, all right, here is your day pass, whole day pass. So then you will go to Ticket Server and say, well, I want to print right now, and here's my day pass. So then it will give you a ticket for the print server, and you can talk to the print server, back and forth, back and forth. Then you want to go to some other server. You don't have to go to the Authentication Server again. You can use that day pass whole day for different servers. You want to log in here, you want to log in there, you want to do this, you want to do that. So you go to Authentication Server, you authenticate in the morning, and you're done. All right, and so they invented this long-term ticket. This is a long-term ticket, and this is a short-term ticket. Right, so they broke this into two pieces: a short-term ticket and a long-term ticket. And so you authenticate once, and then you can use it for many times. Just to remind you again, Kerberos is a system for user authentication protocol developed at MIT. And that way you could log in at any place in the campus and use any services anywhere on the campus. All right, and they did this by using a KDC, which actually was broken into two pieces. KDC was broken into two pieces, one called Authentication Server and one called Ticket Granting Server. So the Authentication Server is where all your passwords, etc. will be stored. So that requires a lot of security, whereas ticket granting server doesn't require that security. Although both of this could be in the same computer because it doesn't take that much power to do either one of the two. However, functionality is separate, and so they just present it always separately, right? So first thing you do is you authenticate with the authentication server. You provide your password or whatever it is to the authentication server, and then it gives you a long-term ticket. A ticket that is good for a long time, which is in this case as shown here is a day, could be an hour, it doesn't matter, long time could be an hour or could be some time. Anyway, with that 1 day pass, with long time ticket, you go to the ticket granting server and you get tickets, many tickets for many different things that you want to do, because once you have authenticated that you are whoever you say you are, then that ticket is good for many things. So for example, you want to print, you could go to the ticket granting server and you say, here is my day pass, and I want to use the print server, and then we'll give you a session key that print server will accept. So here's the thing, if somebody compromised this, then the problem would be that everybody will get a day pass for a whole day and then maybe for life, right? Whereas here, if somebody compromised this, it turns out that this can be very easily invalidated first of all, and it might do a 1 hour of damage. Okay, so the damage here is very little, as you will see. That this one is something that you don't change your password for months and years. If somebody found out your master password, then you have big problem. See what I mean? So the tickets are good only for short time, these tickets, and they expire so fast that if we find out that somebody has taken over our ticket granting server, they won't. Actually, it turns out ticket granting server has really no database whatsoever, and so all they will do is not be able to get new tickets, or some new tickets actually will be issued only if the ticket granting server people who have taken over get the passwords, get the ticket granting server's password, which they could. If they tagged it, they could get the TG's password. If they get it, then they can issue it, but then we can invalidate that in a few minutes. All right. So let me say it again, that yes, everything in this chain could be attacked. Say for example, the client could be attacked, right? But that would limit the damage in a space, and then basically we can change the client's password and then invalidate and so on and so forth, right? Good question, thank you. All right, so the key things to notice are a few things. First of all, that there are 2 servers, actually 3 in this mixture. One is the servers that you need, and then the 2 added to that, which is the authentication and the ticket granting. Second thing is that there are 2 kinds of tickets, the long-term ticket and the short-term ticket, and this is all very similar to what we do, the master password and the session password, master key and the session key, right? Some things are very short-term and you do it many times, and something you do very little, very rarely, so that your security is maximized. All right, so let's go into detail of what these messages contain. I think I have finished all of these. Authentication server is a physically secure node which contains the complete authentication database. So this is something that you don't want anybody to get into. This is logged under key and so on and so forth. Then the principals are authentication server, which is denoted by the letter A, ticket granting server G, client computer C, and user U. Now these 2 are separate. So my computer is separate than me. Somebody can take over my computer, or somebody can take over me. And so the thing is, U is the user and C is the computer, and V is the server that I want to reach. That was the print server. And so each of them have, actually I will come back to this line, but each of them have a key. For example, KCG is the key which is shared by the computer, and the G is the ticket granting server. KCV is the key which is used between the computer and the server that you want to reach. KAG is the key between authentication server and the ticket granting server. And KU is the user's password, and KGV is the G is ticket granting server and V is that server. So some of these keys are generated on this part, some of them are permanent and so on and so forth, but this is the notation. That if there are two letters, they indicate who shares those two, who shares that secret. Alright, now ticket granting server we already said is TGS. Tickets. Now ticket is something that is encrypted information that you cannot reproduce. When you get a ticket, you cannot make a copy very easily. You can make copy very easily, but that would be very easily, basically you cannot be used again. So ticket is something which is encrypted. It's like a black box to you, and you just have to. So it is encrypted using one of these keys. Ticket granting ticket. Now that is the day pass. Right? That is the thing that you get from the authentication server that allows the user to, the computer to get the ticket from TGS. Sometimes we might use user and computer. Actually, all the time we will use user and computer simultaneously as same way. But basically, there is slight detail here where the user credentials are somehow married with the computer credentials, so we know which server which computer he is talking from, and then authenticated that way. So user is authenticated, but the computer is also authenticated somehow. So these are the main concepts. A few more. Authenticator. So authenticator is actually a field, or just like a ticket, it's a piece of a message where name and the time is encrypted with the session key, and it is sent from the client to the server with the ticket, and from server to the client. It says, well, look, here is my ticket and here is my driver's license. Right? So that driver's license is the authenticator. Okay? So basically, so that nobody can replay it. It's not like driver's license is not a very good example, because I can create an authenticator myself. I don't have to go to any place to get that authenticator. It's just my name and my time encrypted with a key that I know. Okay, so there is some kind of secret that is sent. And credentials are basically combination of the two. The session key I know, and I have a ticket. That means I can use the service. And the user enters the name and a password, and the client converts the password to a key KU. And then the TGT and the session key are good for a limited time, 21 hours. So when you get a ticket granting server, and I say it's a day pass, it's almost a day, 21 hours. And why 21 hours, not 24 hours? It's basically the way time is coded in so many units and those so many bits. So the maximum you can code is 21 hours. So this is the fundamental. You get a long-term ticket, you get a short-term ticket, and then you can talk to anybody, right? All right, and I would not be surprised, I don't really know, I would not be surprised if we are using this Kerberos system in WashU. So what is assumed is that the network is open, and so basically everything is encrypted except the first message, and that message is coming up here. Everything is encrypted, and every client and server have a pre-shared secret with AS. So AS is the authentication server, and so every user has to have a password or some secret with the authentication server. It's like your Wushtel key password, right? And every service has the same way with the server. So every print server and any other service that needs to serve the users, they will also have a secret with the KDC, right? Authentication server. And authentication server and TGS are logically separate but share a secret key. So there is a KAG, which is the key between the AS and the TGS. Both AS and TGS are stateless, and that's another strong thing, is that they do not keep any state. So they have given you a ticket, but they forget. They don't have to remember that I've given them a ticket, given you a ticket. So they get your authentication, they give you a ticket, and they can go to sleep. All the state is in the ticket. So anything that needs to be remembered is in the ticket. Day pass is just a longer term ticket. Now, longer term secrets are used less frequently, and short term secrets are created and destroyed after limited use. So that's why we have short term tickets and long term tickets. So that the long terms, you send your user password only, actually you don't send the password, but whatever you do with the password, you do it only once. And then everything else is generated and used and destroyed. And of course, there is, on all these slides I have put references other than the book, which in most cases is Wikipedia nowadays becoming really good, and sometimes it provides better information than the book. If nothing else, it provides additional information than the book. So let's look at the message. So the first message goes in the clear, everything else is encrypted. E means encrypted, right? So this one goes in the clear, and it goes to the AS. So it says, here is your ID, here is my ID, and here is the ID of the ticket granting server that I want to contact. And I'm sorry, this should not be IDA, this should be IDC. So here is my ID, here is the ticket granting server I want the ticket for, and here is the time stamp. Here is the time of the day. It goes to the AS. Now, AS and the client already have a password, already have a secret key, which is established beforehand, right? So AS responds in an encrypted manner and says, well, here are the two things. First of all, here is the key that you can use to talk to the ticket granting server for the next 21 hours, KCG. Okay, it is given to this client. This is a new key. IDG, here is the ID of the ticket granting server. Here is the timestamp 2, here is the lifetime of the ticket, and here is a ticket that you can show to the ticket granting server. And that ticket actually is, so now you see double encryption here. This ticket itself is encrypted. It is encrypted with KG, a secret that G shared with A. Okay? And KCG, this is the same ticket same new secret that has been generated for the day. IDC, ID of the client. ADC is the network address of the computer. IDG is the ID of this one, TGS, and TS2 is the time when the ticket was issued and the lifetime of the ticket. All right. So there are two things. One message is meant for the client, and the whole purpose is so the client know what is the key to use with the ticket granting server. Second thing is a piece of information which is encrypted and the client cannot read it. Client cannot decrypt it. It will use it as a ticket. It will show it to the TGS, and TGS can read it. Is thus clear that there are two pieces of information. Actually, this ticket is somehow encrypted, so there is only one thing, but if once the client opens this, it finds two pieces of information. One is the key, and the second is the ticket. Now the client takes that ticket and sends it to the TGS and says, I want to use this server V. Please give me a ticket for that server V. So let's see what it does. It sends the ID V. ID V is the ID of this server. Ticket that I have gotten, the long-term ticket. Authenticator C, and authenticator is shown in the next line. But anyway, so these are the three pieces of information which are sent here. The ticket itself is as before, the same thing, and basically encrypted thing. And the authenticator is my ID, my address, current timestamp, and whole thing is encrypted with the new key that I have gotten from just now, for this pass, for this day. So this KCG is the day ticket, day secret, and basically here's my name and all that. So the reason this is sent is so that it can match these two and say, yeah, the ticket is for the same person who knows this secret, KCG. So then it sends a short-term ticket, basically again consisting of two parts. One is a ticket which can be used, a short-term ticket which can be used with the server, and a new key that can be used with the server. So read carefully. This ticket is encrypted with what key? I'm sorry, not this script. This message is encrypted with what key? KCG, which is the day secret that the client and the server TGS share, just for the day today. And so both of them know that. So this one encrypts that, and then once the only person who can decrypt is client. Once the client decrypts it, it will find these pieces of information. It will find KCV. That is the key that can be used with the server V for the short time. And the ID of the server V, the time of this key, and the ticket that you can be given to server V. Now that ticket is encrypted. It is encrypted with KV. It is encrypted with KV, so only server V knows this is server V's key. Actually, that is kind of the reason I stopped right there is that I said that the TGS does not know the secret, but it looks like that this V, if TGS knows, then it does have the secret. The TGS knows the secret of all these servers. So anyway, it knows KV, and it encrypts that, and it tells with this ticket it can tell the server that the session key is KCV, and that client is IDC, his authenticator is ADC, you are IDV, and this is the time, and this is the lifetime. So all of this is basically giving the key to the server. Now the ticket is simply returned to the server by the client, and by using this ticket, the client knows what is the key to use. And then the second part is authenticator, which as before is basically ensuring that nobody else can take that ticket. So this authenticator ensures that this ticket is being sent by somebody who knows KCV, who knows the key, and then for that identifies KCV. So anyway, so now the server can identify that thing, and then it sends this TS5 back. Why TS5 is sent back? Because it sends TS5 plus 1, or any function that could have been agreed. In this case, it was agreed that TS5 plus 1 will be sent. Basically, it says that I know CV, so I am B, and so I can decrypt this ticket, and I know KCV, and so here is your proof. Alright, if it goes to some other server, the other server will not be able to decrypt this ticket and will not be able to return this part. Alright, so there is a mutual authentication. The client authenticated with the server, and the server authenticated with the client. Now it might be good just to go over, there is a lot of symbols here. That's why I first prepared this other slide, which is basically, that has no symbols, has just the meanings. And then we have this slide, which is the same messages but in symbols, so that you understand the meaning. First of all, I mean, that brings up a new point, and that is that what about mobility? Right? You said wireless is that if you move, then you have to re-authenticate, you go from here to library. This was designed in 90s. This wireless didn't exist then. First of all, people didn't move that fast. Now, yes, that's the concern, that you would not authenticate based upon an address. You would probably authenticate based upon an ID, which is your MAC address maybe. Right? So you can authenticate not based on an IP address. So you could authenticate based upon your MAC address, and then you go to some other place and you put your MAC address. So this will have to redesign for mobile systems. Also notice that when the user goes to some other computer, they really have to re-authenticate, because that other computer does not know any of the secrets, user secrets. As I said before in the introduction to Kerberos, this is very commonly used today in many different contexts. This has proven successful. I remember hearing a presentation from the inventor of Kerberos. He was our colleague actually from digital. And in those days, we never thought it was so popular, so famous, Steve. But now it's all there. If you want to go to another realm, suppose you want to use the services which are not in the same realm. What is a realm? A realm is AS and TGS. So each realm has its own authentication server. So you are authenticated with Worcester and you want to go to St. Louis University and want to use a printer there. That's a different realm. They don't have your password. They don't have your username. So how do you do that? Well, basically, our authentication server will set up a password with their authentication server. So these two will know each other, right? And once they do, then we all are authenticated. How? You say, well, I want a ticket for the local TGS. And you go to local TGS and say, I want a ticket for the remote TGS. And since they share a secret, just like a server TV, we had, we had a server, we had a secret with the server, we have a secret with the TGS, so it can issue a ticket for the remote server, remote TGS. Then it can go and say, I want a ticket for this printer, and you can get the ticket as usual. And notice that none of this uses any of the certificate stuff, so no public key, no certificates, it's all based upon secrets. This is early 1990s technology. So CBC is what? Cipher block chaining. If you remember, in cipher block chaining, we used to take the cipher block from here and chain it like that. That has some problems. One of the problems was that some of the times the error could go undetected, and there were some attacks that people designed. So by the time this was designed, Kerberos was designed, they changed the cipher block chaining to PCB, plain text and cipher block chaining. So you chain the cipher block and you change the plain text. All right, PCBC. Now with that, what happens is, if somebody changes one bit anywhere in any block, then everything will change. You did this homework. I think if you remember, you did one of the homeworks where we asked you how many blocks will be changed with some errors, and there was 2 blocks and things like that, right? So with PCBC, all the blocks will be changed. So it just provides better integrity.